For this second video, and hopefully our final video on how to write this lab report up, I'm going to direct you to, there's a document called Instructions for Each Section of the Lab Report. So as you're writing each section of the lab report, think about these suggestions. Alright, so describe why we're doing this report. Put this report into context with the peer-reviewed literature. Start describing why this is important. Why or how cyanobacteria blooms occur. What does the literature say about nitrogen and phosphorus? You may also say something about whether or not Wilgreen Lake is impaired. And we're doing this to maybe assess the viability of it as a lake for continued recreational fishing and boating into the future. You may also mention that the lake is impaired, and if you choose to do so, you're going to want to reference all of that. Like, how did you determine that it was impaired? Where did you get that information? If you need help figuring out how to do any referencing, email me and I'll do my best to work with you. Don't feel like you just need to put something down on paper. Email me. I don't care what hour of the day or night it is. Now, with regards to the actual references, there's this link here called Articles and References for Intro and or Discussion. So when I click on it, I get a lot of stuff. Over here, you'll see some of these websites. Some of these websites may not always direct you to articles that are free anymore. So I have put almost all of these in PDF form for you to be able to access. So if you are wanting to cite any of those and you can't open it up on the website, you've got a lot of articles that you'll be able to use. Okay? You want to cite Carlson there. Later on in the discussion section, you'll be able to focus on the water quality criteria. You can talk about the role of nitrogen and phosphorus, how land use may affect nutrients and blooms. There's a lot of information in there. So it's up to you to kind of roll out why this study and this type of work matters and why we're looking at nitrogen and phosphorus. Okay? So those are the types of things you'll put into the introduction. Methods. With regards to the methods, the samples were collected at the Lake Wilgreen boat dock. You've got the date in which we did the lab. If you don't have the date, let me know and I'll look it up for you. The samples were collected within 3 hours of collection time. Secchi depth, we measured that. I measured that at the time of sampling using a Secchi disc. You should tell us the things that were measured. You've got the instructions in the template. If you need to know what instruments were used, the Oakton EcoTester pocket conductivity meter. Nitrate was measured in accordance with the cadmium reduction method using a Hawk DR900 colorimeter. You can click on that and you might actually get the instructions for it. Also on Blackboard, I've got the DR900 colorimeter instructions if you need it, but just saying that you use the cadmium reduction method in accordance with Hawk's instructions, that would be acceptable. You want to mention the instrument. Ammonia was measured using the ammonia Nestler method in accordance with manufacturer instruction using a Hawk DR2800 spectrophotometer. Total phosphorus was measured using the DR2800 spectrophotometer, and the Hawk TNT843 method was used. That method's also, I believe, called the acid persulfate digestion method. Alright, phycocyanin and chlorophyll A were measured using relative fluorescence units in accordance with manufacturer instructions. The instrument that was used was an Amy Science FluoroQuick dual channel fluorometer. Okay, turbidity was measured in NTUs using a Lutron TU 2016 turbidity meter. Now, with respect to trophic state index values, you should describe that trophic state index values were determined for not just each lake, we just did one lake, for Wilgreen Lake, or for the various depths at Wilgreen Lake, using Carlson's paper, or using Carlson's trophic state index, and then cite Carlson 1977. Carlson's TSI was also calculated for the lake using the Secchi depth measurement. So you should consider citing that if you have not already done so. With regards to the results, what does the TSI say about Wilgreen Lake? Is it oligotrophic, mesotrophic, hypereutrophic? Then you should be able to go to the EPA ambient water quality criteria recommendations for nutrients. And also open this document up. It tells you references are based, there's a little typo there, reference conditions are based upon the 25th percentile according to PDF page number 6. And here's the document. The author of this document is the US EPA. The year is 2000. The title is Ambient Water Quality Criteria Recommendations, comma, lakes and reservoirs in nutrient ecoregion 9, or IX there. And then if you want to, you can include the hyperlink there. But if we go down to the page 6, what it says is page 6 of the executive summary. If I can find it here. Here's page 6. Tells you the geographic regions, and we're kind of right there on the edge of nutrient ecoregion 9. Okay. You can also see the percentile value that goes along with this if you start digging into this paper a little bit more. Okay, reference conditions are based upon the 25th percentile according to PDF page number 6. So dig into this. It's got all these different nutrient standards. So I dug into this paper a little bit more for your use. So here on table 2, or PDF page 29, reference conditions for ecoregion 9 lakes. And if you were to look at the total phosphorus value, you can see it's based on ppb, not milligrams per liter, and the reference condition is 20 ppb. What is that in milligrams per liter? So you might want to do your conversion. Secchi depth 1.53. Okay, our Secchi depth in meters wasn't close to that. Total nitrogen in terms of calculated, you could potentially add up our ammonia and our nitrate and see how that value from table 1 compares with this. You'll see that total nitrate, or total nitrogen, and total kettle nitrogen are pretty similar. In this particular one, they've got nitrite plus nitrate. So you could potentially compare our nitrate value to this. Nitrite is usually very low in water. How does our nitrate level compare to this? 0.17 milligrams per liter. So you've got the data. You've got it in table 1. Our values are likely not as flattering or as good, to say the least. All right, so that's the type of stuff that you should be discussing in your discussion section. Okay, now once your results may show that you've got a eutrophic condition, and you may also look on Blackboard on the list, the Impaired Waters list. Here's an Excel file for Kentucky. Citing these is a little more trickier, but it's the Kentucky Division of Water that provided them. I give you a link, but ultimately it gives you this big list here, and off this list you can go over here and search, or you can hit Control F, type in Wilgreen, and see it with your own eyes. Wilgreen Lake. There it is. Just a few spots. The whole lake is impaired. Dam to lake boundary, dam to lake boundary, dam to lake boundary. I'll leave it up to you to open this up to see why it's impaired. Okay, so you can scroll over on this thing and it will tell you why it's impaired. Okay, back to the actual document. Say that it's impaired for eutrophication type reasons, not good warm water habitat, too much phosphorus or whatever. Blue-green algae blooms may be possible. What are the possible health effects associated with blue-green algae blooms? If you need any papers, don't just rely on me saying, oh, it causes liver problems and people who would drink it, or it's bad for the fish or whatever. Don't rely on me. What are some possible problems with it? I've got a link on here, and when we go to our references, there's a folder here called Impacts of Cyanobacteria Blooms, Health, etc. So, what does this mean for people, maybe wanting to swim with it, if they want to make it a swimming lake? Is there the potential for toxins to accumulate in fish? And then there's probably that more general knowledge that you could have periods of anoxia where the fish may die. That's kind of common sense. What management strategies could be put in place? So those other papers that are in the references section of Blackboard, you can look at these. The potential roles of eutrophication and climate change, land use, nutrients, and cyanobacteria blooms article. Takes two to tango. You can open up any of these articles and look through them, and they give some information about what we might consider doing to try to prevent further eutrophication. Should swimming continue to be prohibited at this lake? Where's the phosphorus maybe coming from too? Is it coming from the sediments? Is that going to be something that's going to be hard to deal with? The results show that there was more phosphorus in the lower lake levels. Turnover might free the phosphorus up and it might get in the water every fall and spring. If you have other references you want to use, that's up to you. Part of this class is to teach you how to critically read these papers and then put the proper scientific kind of writing style into play with your writing, where you're paraphrasing the work of others. That's an important skill. And then what are the major conclusions? So going forward, I really encourage you to use these Blackboard resources that are here. And if you have questions in the writing of your lab report, please let me know. It's your chance to impress me that you know how to do this stuff, how to write this stuff up, that you understand it. So if you've got questions, please let me know. This can be a skill set that'll suit you well for a lifetime. So reach out to me if you're having any problems. Thank you, and that will end this video.